All right, guys, in this video we're going to be talking about organic compounds. Now, we've been drawing molecules using the following rules, and the rules in the other videos are probably written pretty similar to this. Find the central atom, find the total valence electrons, attach and subtract, fill the outside atoms, fill the inside atom if you have leftovers, check the octet rule. And we're going to use exactly the same rules. The only difference is, what are organic compounds? These are going to be compounds that only have C's and H's in them. Now, you've heard of these things like propane and butane and octane. If you use a gas grill, that tank that you get is a propane tank, and so you get it refilled, and all you have to do is hook it up to your gas grill, ignite it, and it does your cooking for you. A butane lighter would be like that stick lighter that you would light candles with. Okay, octane is found in your gasoline of your car that makes your car run. And so methane, propane, butane, so I'm going to show you how these things work. We're going to start with something very simple. C2H6. Make sure you draw every single one of these with me as we go along, and I'm just going to show you how to do it. We're going to follow these same rules. Okay, so we're going to find the central atom. Now, what's different in this one is everything that we've done before now always had something had a 1, and this one doesn't. Okay, so the smallest number is the carbon, and so we're going to have 2 carbons. So here's how I'm going to explain this. If you've ever seen the skeleton of like a fish, it's going to have a backbone with a bunch of ribs coming off each side. And so what's going to happen is very similar with these compounds. You're going to have a carbon link in the middle with a bunch of H's around it. So let's talk about this real quick. Carbon is in the 4th column of the chart, which means it has 4 valence electrons. There's its Lewis dot. We've done Lewis dots before. That means there are 4 attachment points for a carbon. So something can attach here and here and here and here. So every carbon's going to have 4 attachment points. Okay? So when we go to draw this, 2 carbons are going to be in the middle. That means in a minute I'm going to attach these. So that means that this carbon could attach to 3 H's in a minute. And this carbon could attach to 3 H's as well. Now notice it says C2H6. 1, 2, 3, 4, 5, 6. Okay? And so it can attach. So we're going to do the same math we've always done. So we found the central atom, so they're in the middle, and then they're surrounded by H's. Count your total valence electrons. So we're going to take all the electrons off, and then we're going to put them back on. Each carbon has 4 valence electrons because it's in column 4 of the chart. And there's 2 carbons, so that's a grand total of 8. Okay? Hydrogen has 1 valence electron, and so I'm going to make sure everybody knows how to do this real quick. Let me grab my periodic table. Carbon is found in column number 4, 1, 2, 3, 4, so it has 4 valence electrons. So everybody here has 1 valence, 2 valence, 3 valence, 4, 5, 6, 7, 8. And the logic is in this last column, they're all full. And as a matter of fact, all atoms want to have 8 in their outside ring when we do this. And that's a quick review. So carbon has 4 valence electrons. Hydrogen is right here, so it has 1 valence. But there's 6 hydrogens, so that's a grand total of 6 electrons. We add those numbers together, and we get 14. All right, so there's our total valence. Attach them and subtract. Well, each line is a single bond. 2, 4, 6, 8, 10, 12, 14 electrons have been used. I ran out. You should run out every single time. I used all the electrons. Fill the outside atoms? I can't. Okay? I can't. I'm out of electrons just by hooking them together. Now, reminder, hydrogen is in the first ring of the atom, and the first ring holds 2 electrons. So as soon as it's attached, it's full. Quick reminder, said in an echo, you will never put dots on a hydrogen. Hydrogens never have dots. As soon as you attach them, they're full. Everybody else could have dots, but not H's. Fill the outside atoms. I can't. Fill the inside. I don't have any leftovers. Check the octet rule. Okay, everybody should have 8. Hydrogens have 2. Every hydrogen is full. That's great. Are the carbons full? 2, 4, 6, 8. 2, 4, 6, 8. There's the molecule right there. It's done. Let's try another one real quick. C3H8. 3 carbons, 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. All right. So let me move that so we can all see it. Great. We're going to do number 2, total valence. Each carbon has 4 valence. 4 times 3 is 12. Hydrogen has 1, so there's 8 of them. Grand total's 20. Notice the numbers are different. You got to do the math every time. So we're going to attach 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Minus 20 is 0. You should run out sometime. Fill the outside. I can't. All the hydrogens are full. Fill the inside if you have leftovers. I can't. I don't have any leftovers. Check the octet rule. The H's are fine. Do all the carbons have 4 bonds, which would be 2, 4, 6, 8. 1, 2, 3, 4 bonds. 2, 3, 4. 1, 2, 3, 4. That's that molecule. Very good. All right. Now I'm going to take this math off because I'm going to come back to these here in a minute. If I get ahead of you, pause and catch up. Now, let's do a couple more. All right. I'm going to grab this one real quick. All right. I'm going to draw a couple of more. This time we're going to draw C4H8. All right. And again, make sure you're doing every single one of them with me. This one's different. 1, 2, 3, 4. Now you may think, how's that different? They're all C's and H's. That's right. They're all organic compounds. That's all they have is C's and H's. 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. I can tell real quick. This one's not full. That's all the formula says. 4 carbons, 8 hydrogens. So we're going to follow the same rules. Total valence. Each carbon has 4 valence, and I got that too close, so I'm going to move that up a little bit. C4H8. Each carbon has 4 valence. 4 times 4 is 16, and each hydrogen is 1. 16 and 8 is 24. Attach 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. I have 2 leftovers. Okay? So now the rule was fill the outside atoms. I can't. They're all hydrogens. They're already full. If you have leftovers, I do. Put them on the center atom. Well, the only carbon that needs help is this one. Got a 0. Perfect. Is everybody full? 4 attachments. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Uh-oh. That doesn't work. Now, what did we do in the other videos? When you're out of electrons and you're still not there, share better. You're going to have to make a double bond. So I'm going to take that pair of electrons and I'm going to make a double bond. Now, here's what's really cool. The double bond can go anywhere between carbons. So you get to choose. You can put it there, or there, or there. Now, can you put a double bond between a carbon and a hydrogen? Nope, the hydrogen's already full, so it can only be between carbons. I'm going to choose to put it right there because I get to choose. But you can choose whatever you want. All right? Now, everybody should have 4 bonds, and I put it there on purpose to make a problem so I can show you how to solve it. 1, 2, 3, 4, that has 5 bonds. Now, if you've ever played with Legos, if you were going to make a car and you stuck a piece on there, it doesn't work, you pull it off and you put it somewhere else. 1, 2, 3, 4, 5. That's too many bonds. So I had that H in the wrong place. I'm going to move it out there because that guy needs help. 1, 2, 3, 4 bonds. Got it. 1, 2, 3, 4, 5 bonds. That's got too many. That guy still needs the help. So everybody should have 4 bonds. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Perfect. Here's how you check yourself. 4 carbons. 1, 2, 3, 4. 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. It's great to do these with a pencil. So this one had a double bond. I'm just going to take the math out. All right. Here's one for you real quick. Pause the video. Try that one. Then I'll draw it for you. All right, let's try this one real quick. 5 carbons, 1, 2, 3, 4, 5. 5 carbons, 10 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got it. All right, so we're going to do our math. Each carbon has 4 valence, times 5 is 20, and each of the hydrogens is 1. Wow, this is going to have 30. Attach them together. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 22, 24, 26, 28. 2 leftovers. Well, we learned on this one right here that if you have 2 leftovers, you have to make a double bond somewhere. Okay? And I told you a while ago, you can choose where you want. So choose where you want. I'm going to put it here this time. Again, it doesn't matter. And so I'm out. Everybody should have 4 bonds to check myself. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. Uh-oh. That one has too many. That guy needs help. 1, 2, 3, 4, 5. That guy has too many, so take one of the H's and move it there. Everybody has 4. 1, 2, 3, 4. 5 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's my they both had double bonds. All right, so if you had two leftovers, it made a double bond. So how do you get a triple bond in one of these? Let's do this. C3, I'm sorry, let's do C4H6. Let's do this one. This one's going to have a triple bond, and I'll show you why. 4 carbons, 1, 2, 3, 4. 6 hydrogens, 1, 2, 3, 4, 5, 6. Wow, you can tell there's not near enough. But that's what the formula says, so we draw it. All right, so let's do our math. Each carbon has 4 valence, times 4 is 16, and each hydrogen is 1. 16 and 6 is 22. 2, 4, 6, 8, 10, 12, 14, 16, 18. Minus 18 is 4. So if 2 leftovers was a double bond, then 4 leftovers is going to be a triple bond. Listen very carefully what I'm about to say. When you're doing organic compounds, how do I know if something's organic? If it is carbon and hydrogen only. Okay? If it's carbon and hydrogen only, you're either going to have all single bonds, or 1 double bond, or 1 triple bond. So if you have 4 electrons, that's 2 more lines that you can make, right? So I get to put a triple bond somewhere. You are not going to have 2 doubles or a double and a triple. Those are way too hard. So if you have 4 leftovers, you're going to make a triple bond. I'm going to put my triple bond right there because I get to choose. Remember I just said you get to choose. Done. All right? So check my work. 1, 2, 3, 4 bonds. Got it. 1, 2, 3, 4 bonds. 1, 2, 3, 4, 5. That H is in the wrong place. Help that guy out. 1, 2, 3. Everybody's got 4. Do I have 4 carbons? Yep. And 1, 2, 3, 4, 5, 6 hydrogens. It has a triple bond. So in these compounds, you're either going to have all single, 1 double, or 1 triple. Here's one for you to try. C5H8. Pause the video and try that one. All right, let's see how you did. 1, 2, 3, 4, 5. 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. All right, let's do our math. 4 times 5 is 20. That's 28. 2, 4, 6, 8. 8, 10, 12, 14, 16, 18, 20, 22, 24. Yep, there's my 4. And so with 4 electrons, that's 2 more lines. I'm going to put mine here. Again, you get to choose. If yours doesn't match mine, that's okay. So I have a triple bond here. 1, 2, 3, 4, 5, 6 bonds. Wow, that's way too many. Got to take 2 off, and that's okay because this guy needs them. 1, 2, 3, 4, 5, 6. Wow, this guy has 2 extra also. Let's put them over here with these guys that need them. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 3, 4, 1, 2, 3, 4. Got it. Take my math out so it's not so cluttered. All right. So it doesn't matter if you put the triple bond there, there, or there, or there. It doesn't matter. Double bond, it doesn't matter as long as it's between carbons. Now, you'll notice there's a pattern. Every one of these look the same. They're just C's and H's. So how do you know what's propane and butane and all that kind of stuff? All right. I'm going to come back to these pictures in a second. Here's what I want you to do. I want you to take a second, pause the video, and write this down, and then I'm going to show you exactly how to do it. Pause the video right now. Write this down. Doesn't make sense until we use it. We're going to do that in a few seconds. Pause. All right. I'm going to show you a very quick one. I'm not going to do the math to draw it, but I'm going to show you how this works. When scientists started finding these in nature, they had to come up with naming them, and they all look alike. So they had to come up with a name. So they had a naming system. So notice in this naming system, 5, 6, 7, 8, 9, 10 are things we've seen before. They're like geometry: pentagon, hexagon, heptagon, octagon, nonagon. We've done that. The first 4 are different. Meth, eth, prop, bute. Okay, and that's not but it's bute. And here's why. You've heard of methane, propane, butane. This is where the names come from. Now here's a silly way to remember them. In order: monkeys eat purple bananas. Meth, eth, prop, bute. So how do you do that? It works like this. How many carbons are in this formula? Well, its formula was CH4. You can tell 1 C and 4 H's. How many carbons are there? There's 1. So the beginning of the word is meth. All right? The ending of the word is either going to be ane, ene, or ein. If it has single bonds, well, that got erased a little bit, sorry. Single bonds, double bonds, or triple bonds. Well, look at the picture. It's all single bonds, so it's methane. Okay? So it's going to be methane because it is 1 carbon with a single bond. So let me try another one real quick. Okay? So let's try some of the ones we drew a while ago. Okay, I'm going to still use those rules, okay, but they're sitting in front of you. Let's look at this one. Okay, look at this formula. 2 carbons, meth, eth. So it's going to be called eth, something. So it's either going to be ethane, ethene, or ethine. That's all there is to it. Well, look at your picture. It's all single bonds, so that's ethane. Check this one. 3 carbons, meth, eth, prop. So it's prop. Look at the picture. All single bonds. There's propane. Oh, that's what the molecule propane looks like when you cook with it. Okay? Propane. All right? Let's look at some of the other pictures that we did. All right? Let's look at this one. C4H8, meth, eth, prop, bute. That's bute. That's the beginning of the word because it has 4 carbons. But look at the picture. It has a double bond. Well, for a double bond, it's either going to be ane, ene, or ine. Double bond, ene. So this is butene. Okay? There's another 4 carbon, bute, meth, eth, prop, bute. But this one has a triple bond. So it's butine. It's real easy. Your picture tells you what to do. 5 carbons is pent. Triple bond, pentine. 5 carbons, pent. Has a double bond, pentene. Super easy. Okay? Super easy. But you have to draw it in order to do it. Now, there's one quick thing to help you with. Whenever you have double or triple bonds, you got to choose where they go, right? Every single time. Now, here's what's super important. When they were learning them, they had to figure out which butene did you have. Because, see, you can have a double bond here. Now, I'm going to use a real example here. If you had butene and it has a double bond right there, it's used in hairspray. But if the double bond's in the next place, it's used in the oil industry. You don't want that in your hair. But how did you know the difference? It's sort of like saying, I have a poodle. Do you have the little tiny poodle or the monster poodle that little kids can ride, if you've ever seen those? You don't know. So somebody who was really smart said, I know. Look at the carbons. They're all in a row. Just count them. 1, 2, 3, 4. He said, look at this picture. After what carbon did you put your double bond? We're going to count this way. After carbon number 1, he said, just call it 1-butene. Okay? Call it 1-butene. That's where you put it. Okay? And they said, well, that's great, but if you took this molecule off a sheet of paper and you had it in your hand, you could flip the molecule around. He said, yeah, count from both ends. If you count this way, it's after number 1, but if you count after this, it's number 3. Let's always take the fastest route. So if I counted 1, 2, 3, it came after 3. That would be 3-butene, but the fastest way to get to the double bond is going this way and call 1-butene. Let's try another one. Count this one. After carbon number 1, 2, 3, it would call 3-pentene. But if you count from the other way, 1, 2, that's a faster route. So this is called a 2-pentene. Try these real quick. Pause the video, try these two. All right, if you count this way, it is after 1, 2, 3. If you count this way, it's after number 1. So that's a 1-butine. If you count this one going this direction, it's a 1-pentine. If you count this way, it's after number 1, 2, 3, 4. So 1 is the shortest route. So the number tells you where the double or triple bond is. All right? Now, real quick for you. See these first ones we did? Do you see a double or triple bond? No. So there's no number because they're all single bonds. They're all the same. All right? So whenever you have a double bond or a triple bond, your name just matches your picture. As long as your name matches your picture, you get it right. So if you wrote 1-butine, then it needs to be in position 1, whether it's after the first carbon going that way or the first carbon going that way. It doesn't matter. But your picture has to match your name. It's really, really easy. Okay? So what happens if I gave you one, and this is the last one, so watch this carefully. What if I wanted you to draw a 3-heptine? I want you to draw that one. Well, that's easy. Here's why. Hept means what? 7. 7 what? Carbons. 1, 2, 3, 4, 5, 6, 7. What does that mean? Triple bond. At what position? 3. 1, 2, 3. Would that work? Yep, it would. So I know that it's C7 and it's H something. So how do I finish them up? Well, they all have H's. Okay, I don't even have to do the math. Watch this. This guy can hold 3. This guy can hold 2. This guy can hold 2. 1, 2, 3, 4. That guy's already got 4 bonds. 1, 2, 3, 4. That's got 4 bonds. 1, 2. This guy can hold 2 more. And this guy could hold 3. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C7H12. Look at me. The name told me how to build it. So I want you to try one real quick. Last one. If I got ahead of you, pause the video and back up. Here's one for you. I want a 2-hexine. Draw that molecule. Pause the video, and we'll come right back. All right. Hex means 6 carbons. 1, 2, 3, 4, 5, 6. Ene means a double bond at position 2. 1, 2. I could put there, or I could put it 1, 2. I could put it there. It doesn't matter, but I get to choose. All right. So I know it's C6H. Let's figure it out. Hook them all together. H, 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 H. 1, 2, 3, 4. That's full. 1, 2, 3. That can only hold 1. 1, 2. That can hold 2. That can hold 2. And that one can hold 3. And I would attach them all together. Almost done. Got it. How many H's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C6H12. That's all it is to it. Organic chemistry or organic compounds are really, really easy. Hey, just from the beginning, just a reminder, we did these rules every single time. Remember, H's never have dots. The only difference between this and the others is we just had to learn how to name them. And they're super easy. The name tells you how to build it. Monkeys eat purple bananas. Meth, eth, prop, bute. Pent, hex, hept, oct, non, dec. Those are easy. Ane, ene, ine. Now it's your turn to try it out. Good luck.